We have both Ed, who's our next official speaker, and Bill approaching. Bill's going to talk to us for a couple of minutes about the password information he put up earlier. But before we do that, Bill, we had a visit from the fire marshal this morning, and he or she is very concerned about people sitting on the stairs out there. Rodney, are you here? I think the problem is those sitting on the stairs coming down. So don't do that. What?
I put this slide up during the morning break, and people have come up to me and wondered, you know, are you trying to embarrass people? Are you trying to single people out? No. Anytime I'm on a wireless net with lots of people, I run this program called DSNF. It's easy to find. It's out there. It's a tool that looks for passwords. And I was shocked to see how many passwords were just there to be grabbed out of the air at a meeting of so many people who should know better. Someone sitting in the parking lot with a laptop and a WaveLAN card can get this same data, except they also get the usernames and the IP addresses. So they can read your mail, they can send mail as you, they can log in as you, they can do whatever it was that you were doing when your password got sniffed. Yeah, okay. No, see, I'm not here to embarrass anyone, so I'm not going to publish the usernames, but anyone who finds and runs and installs DSNF will know much more than is on this slide. So be very careful about what you do. Use encryption for everything. Most people, the question was how many people have DSNF on their laptops? And how many people are downloading it right now?
Okay, I'm here to talk about the progress with DNS security extensions. And the DNS security extensions, the only background I'm going to give you really is this one point. It's a set of improvements to DNS to make it more secure, to make it harder to attack the DNS and to make it harder for DNS to help you attack something else. In the past 2 years, there have been a bunch of hands-on workshops run on top of this technology to try to put it into shape to be used. People want to use that. They've sponsored these workshops. What I'm going to talk about today is what's happened in the past, basically really in the past year, in terms of the workshops themselves, and then the lessons learned and the issues we still have remaining that have come out of those workshops. Not used to IBM or Windows paged. Computers are lovely. Spacebar. Okay. Okay. For a background of DNS security, I gave a presentation last summer at the NANOG in Albuquerque, and the link is up there if you want to look at that. Workshops seem to be somewhat fairly unique in the IETF process. One of the unusual things here is that in DNS security, we only have one code base really to work from. We have a few partial implementations, but only one real implementation. And with the IETF being about interoperability, it's hard when you only have one thing doing something. So to help the specification come along, we get people together and look at the specification, look at the software we have built, and see if we like what's specified, if we like the software, and so on. There are a couple of objectives of the workshops. Number one is education, to get the idea, get what DNSSEC is about out into the community. That's somewhat important, but the IETF really isn't about the education. What we're really after is testing the specification in the software that we have, that we're putting out there. We want to make sure the specification is correct so that when the next round of implementations come around, everything will interoperate. And finally, the biggest thing that needs to be examined here is the inter-zone administration interface. There is a lot of interaction that has to be set up between the management of one part of a network and the management somewhere else. Delegation, right now, you pay money, you get a name, you're given, and you set up your DNS. Now you'll actually have to go back and forth with your parent and with other places to make sure the security works correctly. Now, this is a list of some of the more recent workshops. This isn't all of them. This is just the one since the last time I talked at NANOG. I put this up here to give you an idea of the spread geographically of who's interested in this and kind of the how often they've occurred in the past year. There's 6 here, about 12 months, but 1 every 2 months. And one of the highlights that's come out of this work is the startling realization that DNSSEC isn't just one thing. It seems kind of obvious when you look at the way where we are now, but it wasn't obvious when we started out. DNSSEC really has a bunch of components. Some of them are ready to be used, some are not really ready to be used, and we're beginning to separate that in the workshops, at least, trying to document the ones that are more mature in one way and the ones that need more work we spend more time on. We are making progress on the interface between the parent and child of a DNS zone. That's taken a lot of work. It still needs a lot of work. The good news here is that although we haven't set up the answer of how to do it, we're getting a lot of input from a lot of different places. It's not just 1 or 2 people back and forth arguing over something. I think we've counted up about at least a half dozen different organizations have been involved in the debate. Now, the workshops themselves usually consist of about 24 people coming in to set up a DNS, to play with the software. And usually there are about half dozen people who have done this before, who actually regularly attend all the workshops. One of the things we have to do here is we have to augment the root zone with our own test zone to make this work since we're playing with DNS. And I'll come back to that later in the talk as an issue. Typically what happens is we have the students set up, from a second level domain, we set up subdomains. We have people set up a brand new DNS from scratch there. Some people come in with their own data and just rename the data. Some people come up with from scratch and come up with new zones. We set up secondary relationships, pretty much ad hoc within the room. It's a little harder to set that up because we don't know exactly who's going to attend the day of the workshop. We just typically have people who don't show up at the last minute, believe it or not. We have an initial round of keying, setting up the secure zones, and then we try to rekey the zones because rekeying seems to be more of an issue than the initial keying. I'm going to spend a few slides, one slide on each of some of the bigger workshops we've had. Try to highlight what happened in each one of these. The Vosby workshop is the most recent workshop we had in Sweden. The workshops we've had in Sweden have been the more formal affairs, which invited attendees are there. They tend to know a lot about DNS, and we spent 2 days there, back to back, going through the software and specification. When we were there last fall, we went through the first time we had a HTML set up a web interface for people to submit keys to the fake root or the fake top-level domain we had up there, and we were able to get through some things. The problem we had there was when the top zone tried to re-sign itself. We found out that we didn't have a good fallback for all the delegations when they had to go and get the new signatures. Lateral signing I have on the bottom here refers to something that's come up recently. If you look at DNS tree is very delegated, very hierarchical binary tree, or a tree. It looks like a binary tree, and delegations go up and down that. We found that at times you want to be able to check signatures going across a zone instead of going straight up the tree. You might go sideways within the same zone. And we do that because of key management. And the need for that lateral signing came up in Sweden and was really strongly recognized as what it had to be, and finally got written into stone there, I guess. After NANOG 20, which was back in Washington, D.C. about 2 NANOGs ago, we had a one-day workshop which we modeled on the Swedish workshop. We tried to follow as much, but within 1 day. And the difference here is we actually had homework assignments go out to all the attendees that showed up. They were told ahead of time what they had to configure on their machines. Using the HTML interface for the key exchange, found we weren't as successful the second time. It was hard to do it again from scratch. And lateral signing yet still hadn't been done, but it has been implemented since then. At the 49th IETF, we had a workshop that combined DNS security and IPv6. And we found that combining the two topics in a 2-day workshop was hard to explain to people and for people to grasp at the same time. Both of those are very complicated changes to DNS. We looked at the impact of DNS security on the A6 chains and became aware that with A6 chaining, we have a lot of work to do. But when you have to verify signatures in each piece, it multiplies the effect of DNS security. We also had some problems getting the IPv6 only infrastructure up at the time. I can't exactly recall the real detail there, but at the time, the bind we were using didn't like to have just v6 in the network. And finally, one thing that came up there was the desire, the recognized need, that we want to be able to test this over a longer period of time. At the Apricot workshop that was held in February, we finally came around to the realization that the T-SIG really has become very mature. It's ready to be used to protect the secondary transfers. It's a good place to start working on dynamic update. It still needs some work in terms of the regular query response, and I have an issue about that later on. T-SIG, the configuration language for T-SIG has also been taken by bind to be used for protecting other services such as RNDC, which isn't a topic under DNS security, but we're able to use the same configuration at least to get that secured. I have a couple of results. First thing, shared secret is a lot clearer. We're beginning to really understand what T-SIG can do and how it can be used. Zone transfers, the software is already there in Bind 9 to do that pretty easily and pretty cheaply. Dynamic update, I said, there are a few more things to work on with dynamic update in the signed zone, but at least we can protect the updates themselves. And I mentioned the RNDC already. And now one of the things that's come up is it's time to look at 2 other pieces of DNS security, T-SIG and something called SIG0, to see if they can help us out with some of the last parts of shared secret management. We're getting at least initial operational experience. We're a long way from saying this thing has been operationally tested. We're beginning to get some interest from operators. Like I said before, we had a lot of interest from different places and discussions, and a lot of that is coming now from operators and not from theorists. So we've got one of the bottom point I have there is that there have been a lot of decisions we made earlier in the implementation of the specification that we're getting better input on now. Back when we wrote the specs, originally there was mostly people who thought this would work one way. We didn't have a lot of hands-on experience, and so now we're getting a lot more input from real experts who know how to run a network to help us finish off the specs. The value of the key distribution feature is becoming more and more apparent. Besides being able to, DNSSEC, besides being able to secure the infrastructure, it can also be used to put other keys and other information into DNS and distribute that. And it's been found by some people that the feature of storing keys and securing this information has a lot more value than just a secure infrastructure. We're also getting better implementation. We're testing more and more of the bind software, which is kind of the reference implementation at the time. We're beginning to get that in better place. We're still in the situation, though, that DNS security software is still bleeding edge. We're still playing with some of the issues. So the software is definitely going to lag in some places. Issues. I think we should start the issues. One of the big issues now is when you have a zone and you sign the zone with a public-private key pair, your public key has to be signed by ostensibly the parent, so that if I'm building a secure tree, I can see from the parent that you are the legal owner of that zone. The issue that we have here is, where does that proof of ownership reside? That proof of ownership is actually a signature record. The parent takes your key, signs it, puts the signature in a SIG-RR, and place it in the DNS. The specification says that SIG could be the parent or the child. The child shall have it, the parent may have it. But we've been doing some more of the operational work. We realized that it makes more sense for the parent to put this out than the child, but we're not done with the debate yet. We don't know if that's the right place to do things. So we have one issue there that needs to be resolved, and this one is getting a lot of attention. The keys for other uses, application keys, has come up in DNS. There is one overriding issue, which I don't think I have reflected here, is that whether or not this even belongs in DNS. There have been some debates about whether DNS should hold just DNS information or whether it should be used for any kind of information. Assuming that we have application keys inside DNS, the question is, where do they go? Looking at the previous issue where we talked about the parent signature of keys for the child zone, jumped into a discussion about what if I have my zone, the apex of my zone, is used like a host. Like I have a http:// my domain name without the www in front of it. I might have IPsec keys for that host. I might have SSH keys for that host. They would be in the same place as my zone keys, so that means the parent would then have to sign them. And that right away was seen as an issue. We don't want to have the parent signing host information for the child. So we're looking at ways of where to put the application keys. The other issues I have there is subtyping, meaning that when you get a resource record out of DNS, you don't want to look into the resource record to figure out, is this one of many that I actually want to look at? I want to use the resource records as a set. And the size of the message refers to having to add too many keys to an answer. One of the issues that came up after the IETF workshop in San Diego had to do with how do we persistently test DNSSEC, or for that matter, any other additions to DNS. As far as DNSSEC is concerned, we want to have a persistent test environment because setting up DNSSEC from the scratch, it's somewhat complicated, but it can be done. It's fairly straightforward. It takes a lot of work, though. What makes it really hard is when changes occur, when I have to change my zone key. How do I talk to the parent? What happens when the parent changes their zone key? Now, this kind of testing can't really be done overnight. We need to have some time to let things sink in, to see the implications of changing some of this data. So we need to have a bit more persistent way to look at the engineering that we need to do here. So yeah, that plus the comment I made before, we have a faked route for testing. We've got an issue here about making up where do we put this test environment? How do we mimic a root system in an engineering environment so we can test? Now there's another angle on this need for persistence, and that's there have been some other researchers looking at how do I build a secure zone, a secure DNS, which doesn't follow the tree itself. I need to build up other secure relationships with other people around the world. To do this, again, you need more time to really build this up. And it's another situation where we want to have a more persistent test environment. Another issue that's come up is this idea of this new thing called the lightweight resolver daemon, which is part of Bind's latest distribution, Bind 9. And basically, it's taking the stub resolver and replacing it with a more meatier resolver on each host. This may change the way we look at TSIG in queries and responses, although TSIG works for the other situations. We have an issue here now. Can we make better use out of this now that we have TSIG can be protected a little bit better? Multiple implementations is an issue, mostly because from the IETF standpoint of progressing the standard, we can't get to the next level of standards without multiple interoperable implementations. It's one of the requirements. Bind has taken a lot of work to get where it is. It's one complete implementation. There are other implementations that are popping up. Some are full, some are not. I shouldn't say they're really full implementations. A lot of partial implementations that may help us get to the interoperability testing at some point. We've been getting some legal attention. I actually had to go to a meeting a couple weeks ago involving some of the lawyers in Europe who have been looking at what does it mean to deploy DNSSEC. What's the legal ramification of basically guaranteeing someone that this is going to be your public key I'm distributing for you? There's a little bit more of an issue there. One interesting twist here, this is a legal issue. It's international in scope because, again, we're talking about something that goes across borders. There's one other issue that I didn't have a slide for because it really hasn't gotten a whole lot of discussion, but it has to do with how to deny a data exists. Right now when you get an SOA record back for something you ask for, NX domain, it doesn't exist. We call that authenticated denial. The NXT record, for those of you following DNS security, know that that's the current proposal and it's in the specifications. But some people haven't really been happy with that. We have another proposal out there, and that really hasn't gotten that much of attention, but it's an issue that's out there. Finally, I have a couple of unstudied areas. One unstudied area is how we jointly administer a zone. For example, reverse mapping zone. We have the RIRs managing enatter.arpa, but only one can really put it out. We haven't looked at how we could have two people sign the zone together. And also, a lot of issues that are cryptographic really have been kind of shied away from in a formal manner. We haven't looked at the length of key and how that impacts security, how long the key will last when it's being used in DNSSEC. Although that issue has been raised. As far as the documents, there's a new round of the specifications that are being worked on. The editing for that has begun. We have to include some of the updates that have come out. We have to clean up some of the specification language to make it a little more clear about how this works for people who want to test to see if things are compliant. And that's just going on now, basically through the DNS EXT working group. And the current discussion forums we have are these three mailing lists. DNSSEC at kfax.sc is a mailing list which isn't on the IETF web pages. It was set up as a result of one of the workshops about 2 years ago. And recently we've moved a lot of the DNSSEC discussion to that list to keep it off of the other the IETF DNS mailing list for the time being, because a lot of the discussions cross the two boundaries. Name droppers is the DNS extensions working group, and IETF DNS op is for DNS op, to talk about operational issues. And with that, I'll open the floor for questions.
Yeah, two things. First, I want to take issue with a word that you used. You used the word improve. So the DNSSEC is an improvement to DNS. I will agree that it is an extension to DNS. The second is, just as a matter that might be of interest to some people, there probably will be a bind 8.3, and it will probably have every bit of DNSSEC stripped out of it, because it is now doing more harm than good. It doesn't do validation. It doesn't do a number of things that bind 9 does. So it isn't really part of any interoperability experiment, and it doesn't really do anything useful. But the last couple of cert advisories on bind 8 all came from that code, so stripping it out seems like a feature.
Simpler is better. I had heard from some folks who were involved with the bind 9 tree and the development, and there was a statement made by a nominum representative that they were going to be wrapping up sometime this year. That makes me a little bit concerned if the DNSSEC code is, as you stated earlier, in a state of flux still. Does this bother you at all?
Yeah, it bothers me.
Does this mean that it's something we should take Paul's lead and just sort of turn the blind eye to DNSSEC?
I don't think so. It's contractually, the contract funding it is due up sometime next few months. That doesn't mean that there won't be any more work on it, and doesn't mean that there might be more money later on found for it. But I think it's getting somewhere where it's close enough to be working, but still not there yet.
Yes, I'm switching hats rapidly here. As a, I guess, a representative of Nominum for this trip to the microphone, I will say that there's no plan in place for Nominum to deliberately stop working on DNSSEC or to deliberately stop working on bind 9. There are other priorities, there are funding questions. It turns out that even though there are 50 passwords on the screen earlier, there was a great unawareness of the need for security in the industry. In particular, DNS cache pollution is just as easy now as it has always been. The protocol is completely defenseless against putting things into intermediate caches that will cause e-commerce transactions to take place on servers other than the ones you thought you were talking to. And yet there's just no public awareness of this. So the folks who want to fund Bind9 follow-on work generally treat DNSSEC as the sort of the odd thing that they see no reason for and no reason to spend time or money on it because their users are not screaming for it, and so they, as Unix vendors who ship Bind9, just don't care about it. I would like to see that awareness increased because I think it's important. I happen not to like the DNSSEC specification, but it's what we need, so I'm in favor of completing it. And Nominum will be there to help complete it in some form, as the Internet Software Consortium will be there to help complete it in some form. So there's no abandonment being planned. So when I find Bill, I'll explain that to him with a Nerf baseball bat. Thanks.